So this right here that you're looking at right now is Connect 4, and we can see that there are multiple columns that are indicated by the cursor and highlighted in light yellow as I hover over it. And each time I click, a red or a yellow circle will drop down as if we're playing a normal game of Connect 4. And I can continue to do this until a winner is decided. And as you can tell, this is a very beginning product for what our Connect 4 will look like in the future. It will definitely look a lot better than this, but this is what we have so far. And yeah, we'll continue to improve on it. This game uses circles from the JavaFX package, and we created a specific disk class that extends circles as our structure. And it uses a backing structure of 2D arrays. For our second game, our team worked on 2048. Here is a display of a current 2048 game where the player can choose to move up, down, left, and right using the arrow keys or by also pressing the controls at the bottom. Each time the player moves, a random untaken space is chosen and a 2 is added there to keep filling up the board. As the rules of the 2048 game state, similar numbers will be added, and the game ends when the player fills up the entire board. Again, this game does not look very pretty right now, as of now, but our team will continue to work on it and improve it going forward. There's also an indicator at the top that shows how many points the player currently has, and there's also a button for the player to restart and start a new game.
This is our implementation of Game 3, Blackjack. Right now the front end is just a prototype and we have it integrated with our already written backend. As you can see on top and middle there are two buttons showing dealer cards and player cards. They're just placeholders for the actual cards and you won't be able to click on them even when the game is complete. In the bottom there are two buttons showing take more and stay. These are actual buttons that you will be able to click, and you can click take more to take more cards to get you closer to 21, and you can choose stay to take the gamble and see if in the end of the game the dealer will be further away from 21 than you, in which case you will win the game.
So for sprint number 2, we did a sequence diagram, which just details a process that the player can go through using our app. And for this one specifically, we chose to show off the game we implemented for sprint number 2, which is 2048. So I'm not going to go through the entire thing step by step because we have to keep this video short, but I'll zoom in a little so you can see it better. So basically the player can open the application and go to the settings page, then he can do some stuff with the settings, and then this basically details the functions that 2048 has, including actually playing the game, displaying everything, and updating the player's high score and points. And then he can use those points to change his background on the home page through the player database and the store page. So again, we can't go through everything because we're trying to keep the video short, but here's everything if you wanted to look at it closer. So now for sprint number 3, we did a robustness diagram, and this just basically details every use case that the player can do in our application, such as going through the homepage, settings page, store page, and game screen. And it details all the functions and things that actually happen when you visit those pages. And it also lists all the entity objects that are found through each of these use cases. So it fits all the rules for robustness diagram. And again, I'm not going to go through everything, but these were our 2 diagrams for the sprint number 2 and 3.